Do is determine the oxidation number of each element in the following compound for sodium, Na2 and oxygen, and also the H2SO4. So if we look at the periodic table, that's kind of the key to this thing. For sodium, Na, one second, there, Na. You look at the periodic table and you find it's right over here. This guy has one too many electrons. He's got one valence electron on his outermost shell. If he lost one electron, he would have the same electron configuration as neon, but he doesn't. He can't fill his octet role, so he's pretty upset about that one extra electron. So he wants to get rid of it, which means he will have a naturally a +1 kind of charge tied to him. And then the oxygen, the oxygen up here, this element right here has too few electrons, because this is the perfect, these guys are the noble gases, or not Nobel, but noble gases. They're all noble and royal and everything. And this element, oxygen, is 2 away from that. So oxygen wants to gain 2 electrons. So the oxidation number of oxygen is -2, which kind of makes sense, because if you look at it, the N2O, you're going to need 2 of these guys to balance out with the 1 of those oxygens. All right, the H2SO4. So the H, if we look back over here, this has 1 electron. And in this particular case, for the hydrogen and helium, the outermost shell is can hold 2 electrons. Everything else after that, the outermost shell holds 8 electrons. But it's only because that first shell can only hold 2. So hydrogen is not happy either. He has 1 electron, and he can't just get rid of that one. He wants to gain another electron. So hydrogen is going to... Oh, no, I take that back. He doesn't want to gain. He wants to get rid of it. He wants to get rid of it or share it with somebody. So he's going to create a +1 oxidation number, or an ion. He's going to create a +1. The thing about this one, though, is and the oxygen we've done before, and that's -2. We know that oxidation number. The thing about this one is sulfur can be multiple different types of oxidation numbers, and we don't necessarily know which one we're talking about. So, well, let's take a look at the periodic table and see why that is. Sulfur is over here. And so what we can do is we can figure out what it is. And the way we do that is we say, all right, well, if there's 2 hydrogens, then I have a +1 for my hydrogen, but I have 2 of them. And then I have the sodium's oxidation number. I'm just going to call it On. And there's only 1 of those. And then I also have 4 oxygens, but oxygen was a -2. And then that's supposed to all add up to 0, because according to the rules of oxidation, for a compound, the total oxidation number needs to be 0. It needs to be balanced in the end. So let's see. If I want to figure out what this is, all I got to do is just say, all right, well, this is 2 + On plus -8 is equal to 0. So let's see, 2 + On is equal to 8, and On is equal to +6. So my sulfur oxidation number is +6.